Hi, so for today we are going to talk about intervention for calculus, solving linear equation in one variable. So we are going to solve 10 problems involving solving linear equation in one variable. So linear equation, we mean that we have ax plus b equals some certain of constant or can be equal to 0. So where a cannot be 0, okay? Because if that would be 0, that would only be a constant. So 0 times x would be, let's say, b equals 0. So we have a constant here that is equivalent to some number. So in order for us to have a linear equation in one variable, the condition must be a is not equal to 0 and uh, we have a degree of 1, okay, in one variable. So for example, we have 3 times x plus 5 equals 2 multiplied by minus 6 minus x minus 2x. So this is an example of a linear equation in one variable. It has only one variable, which is x, and as you can see, the highest degree is 1. So uh, if we solve this linear equation, we are actually looking for the value of x that would simply make this equation true. Okay? And that process of getting the value of x is what we call getting the solution of this linear equation. Getting the solution x. So if we want to get the value of x that would make this equation true, okay, 3x plus 5 equals 2 quantity negative 6 minus x. Okay, if you want to get that minus 2x, the value of x that would make that equation true, we must employ or use, okay, the rules of algebra. So let's try to solve. So this will be distributive. So you have 3x plus 15 equals distributive also. So you have negative 12. 2 times negative 6 is negative 12. And then you have negative 2x minus 2x. Okay, so combining like terms, simplifying. So you have negative 12 minus 4x. So combining like terms, we have 3x plus 4x, transpose this on the other side. Then we have negative 12 minus 15. So that we have 7x equals negative 27. Okay, dividing both sides by 1 all over 7, or dividing both sides by 7, so that you have 7x all over 7 equals negative 27 all over 7. So the value of x that would make this equation true is equivalent to x equals negative 27 all over 7. Okay? That is the value or the root or the solution of this x. Okay, wherein we are going to, if we are going to substitute this x, it would make the equation true. The left hand equation or the left side of the equation will be equivalent to the right side or the right hand side of the equation. Okay, so the value of x here is negative 27 all over 7. So of course, if we can simplify or reduce it to lowest term, that's most the that is the answer most probably. Okay, but since we cannot divide this, this is already in lowest term, we will leave it as it is. Right. So for problem number 2, let's try to solve. We have m minus 2 all over 3 plus 1 equals 2m all over 7. Okay? So in this example, we have one variable which is m, and we have a linear equation since the highest degree that we can find here, okay, is m, or simply 1. Okay? So at first, if we have encountered denominators, we want to multiply the whole equation by what we call the LCD. Okay? So what is the LCD of 3 and 7? Of course, we still have 1 here. 1 all over 1. Understood, that's 1. So what's the LCD of 3 and 7? Of course, it's 21. Okay? So if I'm going to multiply all of the equation by 21, the right side, the left hand of the equation to 21, and the right side of the equation 21, so this would look like this. 21 times m minus 2 all over 3 plus 21 times 1 equals 2m all over 7 times 21. So whatever you multiply on the left side, you also multiply on the right side. So we have 21 all over 3 becomes 7. Then 21 all over 7 becomes 3. So now simplifying, you have 7 times m minus 2 plus 21 equals 3 times 2m, would be 6m. And so for the value of m. So distributive, so you have 7m minus 14 plus 21 equals 6m. So combining like terms, you have negative 14 plus 21. So you have 7m. Okay, negative 14 plus 21 would be positive 7 equals 6m. So transposing to the left side, 6m. So you have 7m minus 6m equals, transposing to the left side or to the right side, positive 7, this becomes negative 7. So 7m minus 6m would be m equals negative 7. So the value of the equation that would make this true is negative 7. So in order for us to check, last time we haven't checked, okay, we are going to input the value of the m to make sure that the right or the left hand equals the right hand. So if I'm going to input, we have negative 7 minus 2 all over 3 plus 1. Then we have 2 times negative 7 all over 7. So obviously the right hand side is much more easier to solve. So negative 7 divided by 7 would be negative 1. Negative 1 times 2 would be negative 2. So the result of this must be negative 2. Let's try. So this would be negative 9 all over 3 plus 1. So negative 9 all over 3, that would be negative 9 divided by 3 would be negative 3. So negative 3 plus 1 equals negative 2. So negative 2 for the left hand side, because negative 3 plus 1 is negative 2, equals negative 2. So the answer that we have gotten in m equals negative 7 is true, since it makes the equation true. Right? Alright, so for number 3, let us try to solve this. 5 all over 2y minus 6 equals 10 minus y all over y squared minus 6y plus 9. So the very first thing that we're going to do is to simplify first. If we can factor something, factor it. So in the first left-hand side of our equation, we can factor out 2. So that's why it becomes 2 times y minus 3 equals 10 minus y all over y squared minus 6y plus 9. If we factored it, that would be y minus 3 and then y minus 3. Okay? So basically, okay, if you're going to multiply all of this, cross multiply, shall we? Okay. If we do that, that would be 5 times y minus 3. Then you have y minus 3 here. Then equivalent to 10 minus y. All over, we have 2y minus 3 in here. Right. So first, we need to get the LCD first. So the LCD here first, if we are going to, if we have the same denominator, okay, you need to have LCD, okay, first. So you have y minus 3 squared, of course, these two, and then of course the 2. So if you multiply it, 5 all over 2y minus 3, okay, equals 10 minus y all over y minus 3 squared, okay, by the LCD. Okay, we only cross multiply if they have unique, okay, if they have unique denominator. But if they have common, we need to find the LCD. So you have 5 y minus cube, y minus 3 squared all over 2 multiplied by 2 all over 2y minus 3 equals 10 minus y. You have y minus 3 squared times 2 all over y minus 3 squared. Okay, so you're going to cancel some. So it's going to cancel here, cancel, cancel, cancel. You also have to cancel here. Okay, so you are now left with 5y minus 3 equals, you have 2 times 10 minus y. Okay, and then you try to solve for y, you have 5y minus 15 equals, distribute this, 2 times 10 would be 20. 2 times negative y would be negative 2y. So combining like terms, you have 5y plus 2y equals 20 plus 15. I just transpose 2y, negative 2y to the left side and transpose negative 15 to the right side so that their signs changed. So you have 5y plus 2y becomes 7y. You have 20 plus 15, that is 35. So dividing both sides by 7 to eliminate 7 here. So now you have y equals 5. 35 divided by 7 is 5. 7, 14, 21, 28, 35. Okay, that is 5. Okay? So for number 3. So we get the LCD first. So the LCD is if we have the same denominator, we need to consider the LCD. But if we don't have, we can just cross multiply. Okay? So, yeah. So for number 4, for our problem today, okay, we have number 4, 2z all over z plus 3, okay, equals 3 all over z minus 10 plus 2. So obviously, we can cross multiply this, okay? So by the LCD, so they are unique, correct? So the LCD should be 7 plus 3 and 7 minus 10. Okay? So of course we have also 1 here. So we can add 1 here, but still it's 7 plus 3, 7 minus 10. So you have 2. I have here to multiply the whole equation by the LCD to cancel somehow the what do you call this? The denominator. So you have 7 plus 3, then 7 minus 10. Okay, so you do that. So you have 2z all over 7 plus 3 times 7 plus 3, 7 minus 10 equals 3 all over 7 minus 10. You have z plus 3, z minus 10, plus you have 2 times z plus 3 and then z minus 10. Of course, this is distributive, okay, if we multiply this. So that's why we have 7 plus 3 multiplied by 2 also and 7 minus 10. So we can cancel. Actually, we can do the shortcut, but I'm giving you, or I'm giving you the right solution so that you may know. 7 plus 3 cancel. On this side of the equation, 7 minus 10 cancelled. So you are now left with 2z, z minus 10 equals, you have 3, z plus 3. Then you have plus 2 times z plus 3 and then z minus 10. Okay? So, distribute 2z times z, that's 2z squared minus 20z equals 3z plus 9. Then you have to foil this. You have z squared first, then outer negative 10z, then inner, that's 3z, and then last negative 30. So we simplify this. Z squared, negative 10z plus 3z is negative 7z minus 30. Take note that this is multiplied by positive 2. So let's try to distribute. So that becomes 2z squared minus 20z equals 3z plus 9 plus 2z squared minus 14z minus 60. Okay? So as you can see, 2z squared will cancel. 2z squared and 2z squared here. Okay. So now we are left with negative 20z. And then we have, to simplify, combine like terms, 3z and negative 14z. So that would be negative 11z. 3 minus 14. So negative 11. Then we have plus 9 minus 60. So that would be negative 51. Alright, combining like terms. So of course, I have negative 20z plus 11z equals negative 51. So negative 20 plus 11z, that would be negative 9z equals negative 51. Okay, so divide both sides by negative 9. So this would cancel, and we have z. Negative times negative, that would negative divided by negative would be positive. So is 51 divisible by 9? 19 to 76, 5, 54. No, but they are divisible by 3. Okay, so basically, if we multiply or divide that, we have 50, we have 3, 21, we have 17. Okay, so this would be 17 all over 3. So that will be your value of z for this given problem. 17 all over 3 for number 4. Alright, so what we did, we just get again the LCD, okay, to be able to multiply the whole LCD on the linear equation, and after that, we just eliminated the denominator and simplify the following expressions or the following equation. Alright, so for number 5, we have 2 all over x minus 2 all over x plus 1, equals 4 minus 2x all over x plus 1. So obviously, the LCD of this would be x plus 1 times 1 because of 1 here, but still x plus 1. So technically, we are going to multiply this whole equation by x plus 1 to eliminate the denominator. So you have x plus 1. So you have 2 times x plus 1 all over x plus 1 equals, you have 4 times x plus 1 minus 2x times x plus 1 all over x plus 1. So as you can see, the denominators will cancel this and this. So you now have 2 equals 4 times x plus 1 minus 2x. Okay? So simplify, distribute. So you have 4x plus 4 minus 2x. So combining like terms, you have 2 minus 4 equals 4x minus 2x. So you now have negative 2. You have 4x minus 2x is 2x. Divide both sides by 2 to get x. So you have negative 2 divided by 2 would be negative 1 equals x. Or simply x equals negative 1 for our root here. Alright, so that is for number 5. How about for number 6? So we have 10 problems here. So please bear with me. So you have number 6, 2 all over x plus 1. Okay. What number is this? This is number 5. 4, 3, 2, and 1. So 3 is, then we have 2z. Okay. And then we have 2 all over x plus 1. Okay. So now we have number 6. So our number 6 would be, we have 2 all over x plus 2. Okay. Equals negative x all over x squared plus 5x plus 6. So let us try first to factor the denominator. So we can factor out x squared plus 5x plus 6. Think of two numbers that when we multiply, it's 6, positive 6, and when we add, it's 5. So that is 3 and 2. So you have x plus 3, then x plus 2. So factoring the denominator allows us to have a better view of what will be the LCD. So the LCD these are repeating. We can see x plus 2. So obviously we need to have x plus 2 here. And then we have x plus 3 also. So that would be 2 all over x plus 2. Then negative x all over x plus 3 times x plus 2. We multiply the whole equation by x plus 2 and then x plus 3. Alright, so that's what we are going to do. So you have 2 times x plus 2 times x plus 3 all over x plus 2. Then you have negative x, so we have x plus 2, x plus 3 here, all over x plus 3 and x plus 2 here, of which we can see that that would cancel. X plus 2, x plus 2, x plus 3, x plus 3. So now you are left with 2 times x plus 3 equals negative x. So simplify. You have to distribute 2x plus 6 equals negative x. So now you have 2x plus x. Transpose here. And I'm going to transpose positive 6 on the right side. We have negative 6. So that would be 3x equals negative 6. 2x plus x is 3x. Divided by 3. So negative 6 divided by positive 3. That would be negative 2. So the answer here would be negative 2. Okay. Right. So for number 7, we now have 2 multiplied by 3 minus x all over 4 equals, we have 2x plus 5 all over 3 minus 1/3. Okay. So first, okay, before I get the LCD, okay, I have to rewrite the right side of the equation as 2x plus 5 since they have 3 the same. So I can rewrite this as 2x plus 5 minus 1 all over 3. Now I'm going to distribute this. This would be 6 minus 2x all over 4. And honestly, we can still simplify, okay, the right-hand side. So you have, okay, we can simplify. I think we can simplify this. Okay, that would be 1/2. 2 all over 4 is 1/2. So you have x all over 2 equals, you have 2x plus 5 minus 1 is 4 all over 3. Okay, and then get rid of the denominator. So for the LCD, we have 3 times 2 or 2 and 3. 2 and 3, so 6. 2 times 3, so 6. So we have to multiply it by whole side of the equation by 6. So that would be 6 times 6 minus x all over 2 times 6 equals 2x plus 4 all over 3 times 6. Okay, so now you have 36 minus, you have 6 divided by 2, that would be 3. So you have now negative 3x. 3 times x is 3x. And then 6 divided by 3 would be 2. So now you have 2 times 2x plus 4. Solve for the value of x. Distribute 2 times 2x, that would be 4x plus 8. Okay, so you have 36 minus 8, transpose. You have 4x plus 3x. Okay, so 36 minus 8, I think that would be 28. Then you have 4x plus 3x is 7x. Divide both sides by 7 to get the value of x. 28 divided by 7 is 4. Then you have x equals 4. 7, 14 to 1. That is x equals 4. So the solution for this linear equation is 4. Okay? Alright. So for number 8, okay, we have 6t minus 1 all over, we have t squared plus 5t plus 4 equals, you have negative 19 all over t plus 1. First, we have to identify or simplify the denominator. So you have t plus 1. What two number, when you multiply, it results to positive 4. And if you add, it results to positive 5. So that is 1 and 4. Positive 1, positive 4. So t plus 1, then t plus 4. Okay? So equivalent to negative 19 all over t plus 1. So the LCD, we have a common. You have common t plus 1. That's common. And of course, we have t plus 4. So we are going to multiply this whole side of the equation by the LCD so that we can get rid of the denominators. So if we do that, we have t plus 1, we have t plus 4. So that would be, okay, the t plus 1 and t plus 4 will cancel here. Okay, so we have 6t minus 1 equals, okay, the t plus 1 on the denominator of the right side, okay, will cancel here. So leaving you with negative 19 and t plus 4. Okay, so simplify, you have 6t minus 1 equals negative 19t. Negative 19 times 4. So we have 19 times 4, 76. You have 4 times, you have 76. Okay? But negative because of the negative here. Okay? Negative here. So for the value of t. So you have 6t plus 19t equals negative 76 plus 1. Now we just transpose negative 19, it becomes positive 19. We transpose negative 1, it becomes positive 1. So you have negative 75. 60 plus 90, that's 25t. Divide both sides by 25. So, to get t. So now the value of t is negative 75 all over 25. So that would be negative 3. A negative divided by positive would be negative. And that is our answer for this problem number 8. Okay. So for problem number 9. For problem number 9, alright, so for number 9, you have 8 minus 4z all over 3z minus z equals 2 minus 10z all over 3z minus z. Okay, so the LCD of here is very obvious. You have the same 3z minus z. Okay, and of course, before that, I'm going to factor first the denominator. I can factor z. So you have 3 minus I can factor z. So you have z. Oops, this must be 3z minus 2. I'm so sorry. That must be 3z minus 2. Okay? So no need to factor. So just an error. Okay? So 3z minus 2, the LCD obviously is 3z minus 2 times 1, or 3z minus 2. So what I'm going to do is I'm going to multiply this with 3z minus 2. So I have 8 minus 4z, 3z minus 2. You have 3z minus 2 here equals 2 times 3 minus 2, 3z minus 2. So I'm just being confused with my writing. Okay? We have negative 10z all over 3z minus 2. Then multiplied by 3z minus 2. So cancel. 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 So now you are left with 8 minus 4z equals 2 times 3z minus 2 minus 10z. Okay? So you have 8 minus 4z. 2 times 3z is 6z. 2 times negative 2 is negative 4 minus 10z. Alright, so you have 8 transpose negative 4 on the left side. It becomes positive 4 equals 6z minus 10z. Transpose negative 4z, it becomes positive 4z. Okay, and then solve. So you have 12. 6 minus 10z is, we have, so the answer here will be 0z. Okay, so you have 6z plus 4z, that's 10z minus 10z. So you have 0 on the right-hand side. So which means this has no solution. Okay? So basically, what we have here is no solution. Because the value of z that supposedly that makes them equal, okay, becomes 0. And 0 is not equal to 12. So basically, it has no solution. Right? So for our last number, problem number 10. So for problem number 10, we have 4w minus 1. And we have w minus 2 plus 8w all over w squared minus 6w plus 8 equals 4w plus 3 all over w minus 4. So first, we need to get the factors of the second rational expression. So we factor w squared minus 6w plus 8. So that is basically w minus 2 and w minus 4. If we multiply w, negative 2 and negative 4, that's positive 8. If we add negative 2 and negative 4, that's negative 6. So obviously that is the factor. So it's very obvious that the LCD here should be what? That's the LCD. That's correct. You have, alright, that's correct, w minus 2 and of course w minus 4. They are repeating, so it's very easy. So multiplying this whole with w minus 2 and w minus 4. Okay, so what happens here? On the first, you have 4w minus 1. The w2 will cancel, w minus 2. So you are left with w minus 4 plus, of course, in the second one, we have w minus 2, w minus 4 canceled. So technically, what will be? It will be just 8w. Then equals, on the fourth term or the right-hand equation, right side, so this will cancel. So you are left with 4w plus 3 times, you have w minus 2. Okay? Oh, of course, this is, of course, products. Okay? In products. So you have first 4w squared, then outer, negative 16w, inner, you have negative w, and then last, we have positive 4. Let us just check. For first is 4w times w, 4w squared. Outer, negative 16w. Inner, negative 1 times w, that's negative w. And the last, negative 1 times negative 4 is positive 4. Plus 8w. Same with here. This is the first, 4w squared. Outer, you have negative 8w. Inner, you have positive 3w. And the last would be 3 times negative 2, that's negative 6. So you just have simplify 4w squared, negative 16w minus w, that's negative 17w, plus 8w plus 4. Then you have 4w squared minus 8w plus 3w, that's negative 5w minus 6. Alright, so basically, what we are doing here, we can cancel 4w squared. Okay. So you have negative 17 plus 8w. That's negative 9w plus 4. you have negative 5w minus 6. So combining like terms, so you have 6 plus 4, negative 5w plus 9w. Okay? So I just transposed negative 9 on the right side and negative 6 on the left side. So that becomes 6 plus 4, it's 10. Then negative 5w plus 9w, that is 4w. Divide both sides by 4 to get w. So you have 10 all over 4. That is the lowest term of that would be 5 all over 2. Okay? They are both divisible by 2. So your w would be 5 halves or 5 all over 2. And I hope you learned with this video, class, about solving linear equations in one variable. I hope you learned something, and please don't forget to subscribe to my channel for more YouTube videos. So again, this is Engineer Abat. See you again when I see you on the next video. Bye.